In this video, pre-cal students will be learning how to find the inverse of a square matrix and also what this inverse matrix can be used for. Okay, so go ahead and copy down your heading for today, please. Your heading is, well, I guess you don't have a heading today, do you? That's kind of funny. Alright, your heading for today is inverses, or inverse of a matrix. Sorry about that. Inverse of a matrix. Lesson 14.6. And be sure and include today's date. Okay? Once again, your heading is inverse of a matrix. Lesson 14.6. And be sure and include today's date. Now, let's start off with an explanation of what an inverse matrix is. An inverse matrix is a matrix that, when multiplied by another matrix, has a product that is the identity matrix. Okay? You might want to copy that down. I'm going to read this again. An inverse matrix is a matrix that, when multiplied by another matrix, has a product that is the identity matrix. Okay? Let me illustrate what I mean, okay? Here we go. Alright, now take a look here. We're going to call this matrix here matrix A, okay? And we're going to call this matrix here the inverse. And by the way, that is how you denote inverse, -1, okay? So, this is matrix A, and this is the inverse of matrix A. When you multiply these two matrices together, notice you get out the identity matrix. And we studied the other day what the identity matrix is. It has to be a square matrix. It has ones going down, top left to bottom right, and all other entries are zeros. Okay? So, whenever two matrices multiplied give you the identity matrix, then you have inverse matrices, or if you wanted to, you could have said that this matrix here was matrix A, and this matrix here was the inverse matrix. Doesn't matter. Either way, when you multiply these two, you get out the identity matrix. Okay? So that's what an inverse matrix is. So, in the future, if I give you two matrices, and I ask you to prove that the two matrices are inverses of each other, isn't that easy? You just multiply them together to see if you get out the identity matrix. That's really simple. So again, in the future, if I say, are these two matrices inverses of each other, just multiply them together and see if you get out the identity matrix. Okay? Pretty simple. Hope that makes sense. Now, let's tackle the topic about how do you find the inverse of a 2x2 matrix. It's actually pretty simple. So here we go. In your notes, please copy this down. We're going to find the inverse of matrix A. Okay? So copy this down, please. And if you're a student that likes steps, I'll give you steps real quick. Find determinant. Invert. The determinant. Swap numbers. Change signs. Multiply the inverted determinant through the matrix. So, as always, students, I'm going to move on. If I'm going too fast and I go like this, and you need more time, just have the supervising teacher pause the video, okay? But these are the steps that you need to find the determinant, or excuse me, to find the inverse of a 2x2 matrix, alright? Now these steps here only work on a 2x2 matrix. Step 1, find the determinant. Step 2, invert the determinant, or in other words, flip it. Okay? Swap numbers, change signs. I'll explain that later. And then multiply the inverted determinant through. So here we go. Let's take this thing. Let's slide it over here and get a little room. Did not mean to do that. Let's see if we can do this. Slide it over here. Alright, now, step 1 is find the determinant. So, multiply up, you get negative 14, so I'm going to put a positive 14. Multiply down, we get 12, so I'm going to put 12. So your determinant is 26. Step 2, invert the determinant. So, 26 is really 26 over 1. So if we flip that, we get 1 over 26. Okay? Now, next, step 3 says, swap numbers, change signs. Now students, here's where most students make their mistakes. They forget which two numbers to change the signs and which two numbers to swap. So, all that I can do is tell you, and it's your job to memorize it, okay? These two numbers right here, you don't move them. You do not move them. You simply change their signs. So 7 becomes negative. Negative 2 becomes positive. Okay? These two numbers here, you swap them. So the 3 goes up here and the 4 goes down here. If they were negative, you would leave them negative. If they're positive, you leave them positive. If one's negative and one's positive, then you leave them alone. You don't change the sign. So if this would have been a negative 4 right here, then you put a negative 4 down here. Okay? If this was a negative 3 here, you put a negative 3 up here. You do not change the signs of these two numbers right here. You just swap places. These two numbers here, you don't swap places. You change their signs. And now step 4, multiply the inverted determinant through. So you take this and multiply it through. So the inverse would be 1 over 26 times each of these numbers would give us 3 over 26, 1 over 13, negative 7 over 26, and 2 over 13. Okay, so this here equals what? What does this equal right here? It equals A to the negative 1. Of course, we call that A inverse. So if this matrix here is called A, then the inverse is called A inverse, or the inverse of A, and there's the inverse of A. As you can see, students, it's a pretty simple procedure. You just got to learn it. It's not difficult. You just got to remember it, okay? Alright, now, you guys are on your own. I want you to try this one. So, whoever the supervising teacher is, go ahead and pause the video and work this on your own. When everyone's done, then turn the video back on, and we'll see how you guys do. Okay, here we go. Step 1, find the determinant. So we're going to multiply together. Negative 1 times 10 is negative 10. I'm going to put a positive 10. Negative 3 times 4 is negative 12. Combine those, you get a negative 2. So there's your determinant. Now I'm going to flip that. Negative 2 is really over 1. So flip that and we get negative 1/2. Now next, these two numbers here, we don't swap them. We just change their signs. So negative 1 becomes positive. Positive 10 becomes negative. These two numbers here, we don't change their signs. We just swap the numbers. So negative 3 goes down here. Positive 4 goes up here. And now take your negative 1/2 and multiply it through. If you do that correctly, you will get negative 2, positive 5, negative 1/2, positive 3/2. And of course, you do not have to put the positive signs. Okay, so there we go. So this here would be the inverse of B equals this right here. Okay. So students, there we go. Okay, that's how you find the inverse of a 2x2 matrix. Pretty simple. Now, let's take this a step further and find the inverse of a 3x3. Okay, now watch carefully and please listen to me. I will not make you find the inverse of a 3x3 without the aid of a calculator. Okay, I will not make you do that. However, I am going to quickly show you how it is done so that you will know, but you will not be responsible for this information. Please do not zone out. Please do not sleep or start talking. It is important that you know how to do this. The only reason I'm not making you do it is the process is so long and so tedious. Sometimes it can take up to 20 minutes, and there's just not enough time to quiz you or test you on this material. But in college, especially those of you that they're going to major in math. You very well could have to know this, especially if you take a linear algebra class in college. So please listen carefully. First of all, here's a 3 by 3 matrix, okay? Now, you're welcome to take notes. You don't have to, but you're welcome to. This is a 3 by 3 matrix, okay? I want you to find the inverse of this matrix. So, here's what you do. You take this and you move it over here, and then you put a dotted line here, and then you put the identity matrix right here, the identity matrix, so it looks like this. Okay, there we go. Okay, now again, if I'm going too fast, for those that are taking notes, just pause the video. Now here's what you want to do. You're going to do manipulations. You're going to do elementary row operations to all these rows, all of them. Okay? And as you do that, your goal is to get this right here to become 1, 1, 1, 0, 0, 0, 0, 0. So in other words, you want this to become the identity matrix. And as you do that, guys, as you make this become the identity matrix, this over here is going to change. Because remember, you're not just doing stuff to these three numbers here. You're doing stuff to the entire rows. For example, if I wanted to get a 0 right here, I would make all of these negative and then add down. This would become a 0. This would become 0. This would become positive 1. This would stay negative 1. This would become a negative 1. This would stay 1. This would be a 0. So little by little, this is going to change over here. So this can take you sometimes, students, a long time. It can really be, trust me, a tedious process, okay? But here's what happens. When you're all done and you finally have this over here in the form of an identity matrix, then what you're left with over here is the inverse of this matrix right here. So I hope that makes sense. That's how that works. So this matrix here and this matrix here are inverses of each other. If you would multiply them together, you would get out the identity matrix, okay? So that's how you find the, not just the inverse of a 3 by 3, but any square matrix. In fact, you could use the same procedure on this problem back here that we did earlier, right here. And literally, just give me 2 seconds like this here. I could say 4, 7, negative 2, 3. And of course you don't want to do this. It's much longer. 1, 1, 0, 1. But you could do it to this. You want a 0 here. You know what, this one's a lot harder. So I'm going to choose a faster, easy one. You could use this one here. You could say negative 3, negative 1, 10, 4, dot, 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 1, 1, 0, 0. Okay, I want a 0 here, so multiply this by a negative 3 and add down. So if I did that, I would get, let's see, negative 3, that'd be a 0, negative 12, negative 2, 0, that'd be a 1, negative 3, that'd be a negative 3. And then multiply this bottom row by 5, and then add up to get a 0 here. So if you did that, you would then have 0, that'd stay a negative 3, negative 10, that'd be a 0. I'm probably making a little mistake somewhere. 5, that'd be a 6. This would be a negative 15, and this would stay 0, negative 2, 1, negative 3. Now, you want this to be a 1 right here, so divide everything by negative 3, and you'd be left with 1, 0, negative 2, 5. And then here, divide everything by negative 2 to make this become a 1. That would be a 1, a negative 1/2, and a positive 3/2. And it worked. Look at that. This here even though it's sloppy, matches this perfectly down here. So the procedure I showed you over here, this will work on any matrix, but of course a 2 by 2 we have a much faster way to do it, the way I taught you earlier, okay? But students, trust me, this procedure takes quite a while, so I'm not going to make you do this on tests or quizzes. However, this method works on any square matrix, so it is a good, solid, consistent method, okay? Alright, moving on. Now, how do you find the inverse of a matrix? By using a grapher. Well, let's take a look at this. Let's go back to the matrix we were just dealing with, okay? Here it is. Now, let's take this matrix here, and let's pretend that we do not know the inverse matrix. So go ahead with your grapher. You should know how to do this. Go ahead and type this into your calculator. I'm just going to pause. I'm going to sit here and be quiet. Go ahead and take this, if you would, students, and type this into your calculator as a matrix, a 3 by 3 matrix, okay? Go ahead and do that. Hopefully you're becoming pretty fast at doing that now. Second matrix, then you first scroll over to edit, then scroll down to the matrix you want, then hit enter, and then enter 3 by 3, and then enter your 9 numbers. And then personally, I always check those numbers. So check them, make sure you've entered them correctly. Okay, I'm going to continue on. Now, students, I'm not sure where you entered this matrix. You might have entered it in matrix A or B or C. I'm going to pretend that you entered it in matrix A. So now that you've entered it, hit second, quit, and clear your screen entirely. Make sure you're on a blank screen. Then go back to your matrix. So hit second matrix, and then scroll down to the matrix you entered this, and hit enter. Now if you used A, up on your screen will pop this. Okay, then if you'll look down the left side of your calculator, should be about the 4th button down the left side, you'll see this button right here. Okay, hit that button next, and this will pop up. And then hit enter. And when you do, this matrix should pop up on your screen. Now that's really fast, and it's really beneficial to know how to use, okay? Alright, so that is how you would use a grapher to find the inverse of a matrix. Alright, continuing on. Finally, let's use inverse matrices to solve linear systems, okay? Let's use inverse matrices to solve linear systems. So here we go. Please take some really good notes on this. Alright, let's start off with a 2 by 2. Now here's what you do, okay? Watch carefully. You take your coefficient matrix and you put it here. 1, 2, -2, -3, okay? Then here, look what you do. You put a matrix that has an X and a Y. Why do I put an X and a Y? Because you're solving for X and Y. And then you put equals, and then you put your constant terms right here. Now students, please listen to me. I want to show you how this works. If you were to multiply these two equations together, you would take row times column, correct? I've taught you that. You know that. So you're really taking 1 times X and -2 times Y. And that should equal 0. And look, that's the exact equation you have here. And then here, when you take row times column, you're taking 2 times X, -3 times Y. And that should equal this right here, 3. And that's the exact equation you have here. So if you don't understand what I just said, that's okay. But I was trying to explain to you why we set it up like this. If you did not understand what I just said, then that's okay. You can still memorize this, can't you? Of course you can. That's so easy to do. Now listen to me. Listen to me, students. Anytime on a test or a quiz that I ask you to solve one of these problems using inverse matrices, you are more than welcome to use your calculator to find the inverse. Please, please feel free to do that, okay, students? So anytime I ask you to solve a linear system by using inverse matrices, feel free to use your calculator when it comes to finding the inverse matrices. So here's how you solve this equation, okay? You're going to take the inverse matrix and you're going to multiply it. You're going to find the inverse matrix of this matrix here. So very quickly, I'm turning my calculator on. You don't have to do this if you don't want, students. You can just watch. I've entered it 2 by 2, so 1, negative 2, 2, negative 3. So I have 1, 2, negative 2, 3. Okay, I very quickly found the inverse of this matrix here. Okay, and the inverse is this. I have no idea how that happened. Okay, my pen is acting really crazy here. Okay, let me use my mouse here real quick. Let's see if that helps anything. Yeah, I'm not sure what's wrong with my pen here, but okay, I'll use a mouse here. Alright, now here we go. Students, my inverse matrix is this. Okay, my pen's doing some really crazy things here, guys. Okay, I might have to use my mouse. Okay, my inverse matrix is this. For the 30th time, it's negative 3. Now I'm using a mouse, so these numbers are going to look a little weird. Then a 2, then a negative 2, and then a 1. So that's my inverse. Now I take my inverse and I multiply it times the side of the equation. So let's stop and review. The first thing you do is you set your matrix equation up. So you take your coefficients and put them right here, okay? Then you put an x and a y right here because your unknowns are x and y. Then you put your constant terms right here, okay? Next, you find the inverse of this matrix here, and then you multiply it times this side, okay? Then, you know, with an equation, if you multiply one side by one thing, you must multiply the other side by the same thing. So I must also multiply this side by the inverse matrix. Students, are you listening? Your inverse matrix must come first, okay? Your inverse matrix must come first, alright? Do not put the 0, 3 first. There we go. Now, watch. These two, quote-unquote, cancel each other out, okay? Because they're inverses of each other, and you get the identity matrix. So we're left with x, y, okay? Now over here, when you multiply this times this, you come up with, and hold on 1 second. Let's see if I have that answer real quick here. I do not, so let me quickly enter that into my calculator. Okay, if you multiply these two together, you will get negative 6, negative 9, and hold on 1 second. Okay guys, I'm back. I knew that didn't look right. That is incorrect. When you multiply these two matrices together, you get 6, 3. So x equals 6 and y equals 3. And you can check that answer if you want. Put it in up here and you'll see 6 minus 2 times 3 is 0. And 2 times 6 is 12. solve. Minus 9, 3 times 3 gives you 3, okay? So that is how you solve linear systems using inverse matrices, okay? Now I'm going to give you one more, okay? Then you can work ahead, or you can stay with me. And then we're just about finished with the math today, okay? So here we go. But quickly, one more time review. Coefficients go here. Your unknowns go here. Constant terms go here. Find the inverse of this matrix right here. And then multiply both sides by that inverse. And you should have your answer. Remember, anytime I ask you to do what? Solve linear systems by using what method? Inverse matrices. You are more than welcome to use a graphing calculator to find the inverse matrices, okay? That is totally fine to do. So here we go. Let me see if my pen is working a little better now. Hopefully it is. And if not, then I guess we'll keep using the mouse. Okay, let's try one more, and then we'll be done for the notes for this video, okay? Here it is. Go ahead and copy that down, please, okay? I'll wait just a second while you copy that down. Go ahead and copy this down, guys. And here we go. Coefficient matrix right here would be 1.06 and then 1. Now for your y's, we'd have a 1, then a 0.075, and then notice there's no y down here, so I'll put a 0. For my z's, I have a 1, and then a 0.095, and then negative 2. Alright? Now next to it, I have 3 unknowns, x, y, and z. And then over here, I put my constant terms. So 10,730, and then 0. Okay? So there we go. Now, remember, the first thing you do after you've done this is you find the inverse matrix, okay? You find the inverse of this matrix right here. Now, let me check my notes and make sure I've copied this correctly. Excuse me, I'm yawning a little bit. Okay, if you find the inverse of this, it will be this right here. Okay? It'll be 15, negative 21.5, 7.5, and I'm trying to stay awake here, guys. I stayed up for the Ohio State National Championship game, and I am starting to get a little tired here, so hopefully I will stay awake here. Alright, this is your inverse matrix, okay? Alright, now look, students, remember what I showed you back here. You take the inverse matrix and you multiply it times this side here, but you also multiply it times this side here. So the same thing here happens, okay? I'm not going to bring all this down, but you understand. I take the inverse here times this matrix here. Okay? And when I do that, like I showed you, these two matrices cancel out, okay? So they're gone. But I must also take this matrix here and multiply it by the right side. So, on the left side, I'm left with this right here. X, Y, Z. And on the right side, I'm left with this right here. This is my inverse matrix times this matrix right here. Okay, remember the inverse matrix comes first. So, if I multiply these two together, I'll have my correct answer. Now remember, when you found this inverse matrix, use your calculator. When you multiply these two together, use your calculator, please, students. There's no reason why you wouldn't. Okay, so x, y, z equals and then here's what you get. You get, if you take take this matrix here times this matrix here, you will get 4,000, 4,000, 2,000. And that is the correct answer, okay? So I hope that's made sense to you. Once again, write your coefficient matrix, then your XYZ matrix, then your constant terms, and then find the inverse of this matrix here, multiply it times both sides, use your calculator all that you want to, and you should be fine. Now, I did not lie to you when I said one more and we'll be done, because I'm not going to do another problem. I don't want to, but I am concerned that you don't know how to do something with your graphers. So I need to show you something very quickly, okay? Just do this very quickly, please. It's not a problem. I just want to show you how to change decimals, convert decimals to fractions within matrices, okay? Let's say I asked you to find the inverse of this matrix here, okay? Now you can take notes if you want to. You don't have to. It's up to you. Alright, now if I found the inverse of this, let's just say you typed into your calculator, okay? So if you quickly type this into your calculator, this is what you would get out right here, okay? This will take me about 2 seconds. Okay, you get this right here. You get, and some of you can try this if you want to, is you'll get 2 right here. Then you get 0.33, then you get, or negative 0.33, then you get 1.166, then you get negative 0.5. Now, students, what if I didn't want decimals, okay? What if I did not want decimals? Well, if you'll take your calculator and hit, now listen to me, math, enter, enter, hit math, enter, enter. It takes all of those decimals and converts them over to fractions. So math, enter, enter. And now it shows this matrix. It shows a 2 here. It shows a negative 1/2 here. It shows a negative 1/3 here. And it shows a 1/6 here. So anytime you get out a matrix, whether you've multiplied 2 matrices together or found the inverse or whatever, and the matrix has decimals in it, and you want it to be fractions, just hit math, enter, enter, and it will convert it over for you, okay? Students, I hope this video has been a help to you. If you have any questions, never hesitate